guys, it's Damon here, and as you can tell, I have officially replicated and made my own bearing block for this Goose Guy S2. There's a lot of prototypes that I can't even tell you how much I've gone through, the amount of challenges and the amount of geometry that you have to go through to be able to make this just right for all the servos to be moving in the right direction without bumping into anything is quite drastic, especially since this is made out of metal and I have to do some 3D printing, so I have to go into some areas that increase the strength, which takes up a little bit more real estate than the aluminum original bearing block, but I've been able to replicate it successfully. I will be doing a test flight with you guys so that we could see how it performs, but I've actually been working on a lot of testing as far as the bearings that fit into the plastic and secure it in a way where it wouldn't move out. I have done some spool up tests without the blades just to make sure that there were no vibrations. I've definitely increased the areas of the supports of the servos because when I originally started replicating this bearing block, well, the areas were too thin, so I had to increase the surface area that the bearing block was touching and supporting the servos, which made a drastic improvement as far as the movement in the servos when the arms are moving up and down on your cyclic and your throttle stick. One of the challenges I had after designing and engineering this bearing block is the wiring. I have been able to successfully wire the cables and mitigate the motor on the bottom since I was using a lot more plastic to be able to beef up the bearing block so it could be rigid and sturdy at the same time. Looking at the original design, the Goose Guy bearing block actually has three main components: the very bottom bearing block, the top bearing block, and then the center section that actually holds the servos. The bearing block I've designed is actually all in one piece. The only second piece I have added onto it is the top, where it secures the bearing into its seated position so that it doesn't come out when I'm flying the aircraft. But besides that, I've also been able to decrease the amount of part count in the bearing block itself. As you can tell, I have two new pieces on this nylon airframe, is the bearing block and the landing skids. Quick note on the landing skids, I've actually designed a whole new landing skid where you could actually 3D print the landing skid all in one piece without using any sort of heat to form them into their original position. So I will have that for you guys on Thingiverse and Printables soon. Just wanted to do some more testing on it and making sure that it has no failure points, but it will be slightly weaker since the way that the printer is printing them is vertically instead of horizontally. So within the bearing block, I've also realized that not only do you have to keep the geometry of 120, 120, 120, because that's how most of the geometry of the servo setups are for RC helicopters nowadays, is that the swash plate, when it's moving up and down, side to side, in all different orientations in positive and negative pitch, there were actually times where I was bumping up against the mounting arms for the servos, so I had to actually cut back on the angle on that and make sure that there was clearance throughout the entire area of where the swash plate was. Also, the movements in the servo arms were extremely important because there were areas where I had too much material, especially on the elevator servo, where I was starting to bottom out on the bottom side of the plastic, and there's also reasoning why there's open areas within the bearing block so that there is clearance for the servo arm to move up and down. With that being said, let's take the heli outside and see how it performs. Alright guys, I have my 3D printed helicopter with the bearing block configuration that I've designed and the PCBWay airframe. So if you want to 3D print with them, I'll leave a referral link down below. But let's see how this bearing block flies and gets tested. wow is all I have to say, guys. The bearing block performed extraordinarily well. I will have to do some inspections, but on the first look, no screws are loose. The servos are still locked in place, and everything looks like it's where it's supposed to be. No complaints. Cables are wired. Nothing is touching the motor, and yeah. So I'll do a couple more test flights, and hopefully I could get this on Thingiverse and Printables. If you guys like this type of content, please like and subscribe, and I'll catch you guys in the next one. Thanks for watching.